Okay, so this agent has been designed to audit the amount of water we're pumping into, to audit the water we're pumping into a water distribution network. So in essence, we are monitoring inflows, outflows, and volume change over a period of time to detect any losses or to determine any gains we're having in the water network. So the first step in doing this is to carry out what we call a reservoir balance process, a reservoir balance or process balance. So all the calculations here follow the law of water balance, which states that inflows of water into a system or an area are equal to outflows plus the volume change in a storage unit over a certain time interval. So we've built in this water balancing agent a flow meter converter. So this enables us to take any flow meters bringing in data in different units of measurement. So say some people measure their water in megaliters per day, some measure in kiloliters per hour. So it just standardizes everything so that the calculations become easy. So the next step is we now calculate the volumes being brought into the reservoir. So there are two common types of flow meters used in the water industry. So the first one is an instantaneous flow meter, which changes every time. Then the next one is a flow totalizer, which just increases all the time. It's a counter which just increases all the time. So for the instantaneous flow meter, we've got mathematical integration inbuilt in the water balancing agent, which calculate the volume of water consumed within a certain time period. For the for the for the counter, for the flow totalizer, we calculate deltas in within a certain time period. So the next step is that we also accommodate multiple inflows and outflows for certain reservoirs. There are reservoirs which feed off of from, say, multiple pipelines or which feed multiple pipelines. So in our configuration of the new water balancing agent, we cater for all those reservoirs as well. So we also have, like any other Android agent, we have process alarms. Process alarms are, in this case, are for high-level alarms or low-level alarms and recovery or under recovery. We also have a bit for which shows fuel status, and we also have a status showing the fuel rate. So this indicates whether our reservoirs are filling up or the levels are dropping, so to alert us to act on it. So as you can see on the far right, this shows the simple configuration of the water balancing agent. So you enter in the dimensions of the reservoir, the inflow tags, the outflow tags, the level tags, and the agent just does all the calculations for you. So when you get all the statistics indicated in gray, it helps us on the next step now where we do demand management. So just like the max demand agent, which was described earlier on, this agent follows a similar working model. Is that we have a full cycle, which is a full day, which is regarded as a cycle, and it's broken down into block periods. So now we can quantify the amount of water used per block period. So this enables us now to track demands and recovery rates of a reservoir. And it helps us now to do demand management in the sense that we know the times, or we know the time periods which we consume the most water. So it brings us a solution in that we will be able to plan our pumping cycles. Now we can be able to choose the times where electricity is least expensive, and we can pump in during those time periods. So the statistics which come in this agent are stuff like the demand, the maximum demand, recovery rates, and process alarms. So the next step is that we log all this data, then we create reports like this one, or this one being shown here. So for this report, it shows that we're able to account for 84% of the water. So there's obviously losses in the system, and we initiate an investigation, or we have to find out why we're losing water. This might be resort to leaks or faulty instruments in our network. So this agent has been built in collaboration with customers in the water industry, and we've piloted it at Joburg Water, and we've installed it at Umgeni Water. So in addition, we've also been working on a machine learning algorithm which can predict or forecast the water demand with based on the historical data which we've collected so far. So in closing, I'd say this agent is assisting our customers to proactively manage the water networks in real time. Thank you.